So let us begin. It's a CN Module 1. So basically, I will be talking about mostly about data and communication, especially. So I'll be explaining this concept to you according to the syllabus copy and also answering this model question paper. So let before starting the explanation, let me just tell you the analytics of this channel. 95% of the people just watch and leave, and they do not like or subscribe. Just 4% of the people who have watched the video, and the remaining of few are 95% are non-subscribers. And it's just not 100 or 15 people. The views were almost 10 to 15,000 k recently. Among this 15,000 viewers, obviously at least 1,000 or 2,000 are the new users, but walk away without subscribing. So I just request you to subscribe. So now let's start with the explanation of this topic, that is data communication. As you can see, I've highlighted the topics. So if you want to know what is data communication, just read this highlighted topics and write it in your. It's nothing but communication is the process of transferring data between two or more devices. Typically, or you can add any other device if you know, through a transmission medium such as wires, optical cables, or sometimes fiber optic wireless signals. So we have to talk about the key components about this data communication. So remember, the components you're talking is with respect to, you cannot add human here, saying the sender who sends the data. It's unacceptable. You have to talk the device originates or sends the data. Receiver is nothing but the device that receives the data. Medium is a physical path through which the data travels, cables and wires. And for wireless devices, it's not actually a physical path. Okay, so network. Message is nothing but the actual data information being transferred. So message and data are both are not the same. Data is something. So message is a type of data. So the data can also be pictures, right? I don't know. You cannot say the picture is a message. It is nothing but actual data information being transformed. It can be data can be other things also. Protocols is nothing but they are the rules ensuring the is in the communication process the device understand each other. So sender and receiving devices. Shouldn't be technical issues like anyone is trying to use some malicious things and all, etc. etc. So that's why these protocols are there. Types of data communication, three types are there: simple, half duplex, and full duplex. Simple data, in simple words, is nothing but a device is only outgoing but no incoming. So the communication is unidirectional, means only from device to another, but there is no receiving. For example, input devices like keyboard, mouse, etc. Half duplex, nothing but both in going there, but it's like you're sending messages in WhatsApp. You can just an example, walkie-talkie. So you cannot receive while you're sending the data. So you have to, in films like they say something and they say over and close the channel, and then the other person opens a link, and so both directions, but not simultaneous. Full duplex is like our normal phones, where we can the flow of data is and at the same times. Key concept: transmission modes. So how the data is sent. So serial is parallel. Serial is nothing but 1 bit at a time. Parallel means more than 1 bit at a time. Network types: LAN, MAN, WAN, PAN. Data transmission: analog or digital, using method like packet switching or circuits. So here is the same explanation. You can just pause quickly and read if you want. Anyways, these PDFs will be mentioned in the description, where the link is provided for the Google documents. You can see there. Main thing you have to remember here is these key points. Always remember to mention this. Just take the screenshot of this so that at the exam, just before the exam, this photo you will understand all the concepts. What is data communication? Simple definition. Components 5 are there. Types 3 are there. Network types 4. Transmission methods: analog, digital, packet or circuit switching 4. So let us move for network and computer network. So here there is a long, huge paragraph talking about networks, comparison of computer networks and distributed networks, as you can see here, and then defining computer networks. Let us read the definition from both the PDFs. A network is a set of devices, often referred to as roads. Nodes by communication links. A node can be a computer, printer, or any other device capable of sending or receiving data generated by others on the network. So you can also see the definition of network over here is same as this previous definition itself, but you can just elaborate a lot in this. So saying the collection of devices known as nodes connect communication links. You can say what are the types of links to share data and other sources. What are the nodes? Printers or other devices which are capable of sharing and sending and receiving data. Not just all the devices, but it should be so. You cannot include a speaker over here, just normal speaker or like something like that. Sometimes speaker actually give the data, right? Like you connect to the and the data is being transferred. Like the data is nothing but the audio files to be played like that. And networks use various standards. Yeah, so you don't have to like remember so much about all these things. You can simply write the medias which are present in your unguided and guided media of this module. So we basically can remember it easily, right? Then key aspects of computer network. So okay, sorry, what is a computer network? Computer network is nothing but collection of computers which are interconnected to each other to share the resource, the data. So you can simply write the multiple devices interact with us. So simplistic connected by single technology to exchange information. First, you have to say collection of computers with a single technology. Then you can say it enables multiple devices to interact with each other for resource sharing and other things. Key aspects you can just see this may be important or may not be important sometimes. What are distributed systems, and you have to do the difference between them. As I said, computer network is just like computers are connected to each other, and each computer will have their own different users. But distributed system is nothing. Multiple independent computer appear as a single cohesive system to users. So many websites are there which can be together shown in one what to say www.w like that. So they have messages. Yeah, example World Wide Web which presents the web pages as a unified document. Use of computer network. So resource sharing. You can simply say hardware and software sharing. Server client model where a man who handles the server uploads the data and anyone can access the data remotely. Just read the definition to be able to understand communication medium. So it's nothing but like your WhatsApp calls, normal calls, text, video calling, and e-commerce is nothing but all over your business like phone pay, Google Pay. So these are the key points which if you just read once should be enough for you to understand. Whereas the components diagrams are here where you see it's not like keyboard speakers or other things. It's just like all these six are here: cables and connector, router, modem, switches, hub, and national interface card. Just remember this, it should be enough, and this completes with network. So we'll move on to the types of network. So computer networks and types. A computer network is a group of computers linked with each other. The computer to communicate with another computer and share their resources, data, and applications. So again, they have talked about computer network. Before saying the computer network types, you have to explain computer network again. Can be categorized by the size. A compute network of mainly four. See types of network: LAN, MAN, WAN, and PAN. So I have highlighted this. You can just study from here, or also you can study from here. So this is actually how to say simplified version, and also an enhanced and uh, like easy to understand version of those answers. So local area network. A LAN is a network that connects computer within a small, so such as buildings or office. So you can just say like your schools and colleges for LAN, or sometimes airports also they use like particular places you have the Wi-Fi, right? So local area, kind of local area network itself. So characteristics typically uses inexpensive hardware. So what it uses? Hubs. So let me just highlight this. Hubs, network adapters, and Ethernet cables, and it offers high data transfer rate, and it provides higher security due to limited site. See, data transfer rates are high. Then usage ideal for small offices, schools, homes where high. Okay, homes. I don't think airport can come in this. It can become kind of wide area because actually airports are very huge and you can have the network like network range throughout the airport except for the plain area. That's it. Then PAN, personal area network. A PAN is a network set up around an individual, typically within a range about 10 meters. So it's personal area which is set up very close to the user or user environment or user table also. You can just for 10 characteristics connect personal devices like laptop, mobile phones, media player, and gaming consoles. First, by Thomas Zimmerman, covers a very limited area around 30 feet. Users for personal device connectivity such as syncing data between a smartphone and laptop, or you can simply say a router to your laptop. Metropolitan area network. So I have to also show you the photos, right? So this is your local area network, like your college labs. See here, twisted pair users, twisted pair less costly, inexpensive hardware, hubs networks, and data transfer is higher security. I have also highlighted this individual person range of 10 meters, computer devices of personal use. Windows is used for connecting computer devices for personal use, known as personal area network. This man has created first covers an area of 30 feet, and this is the networks where you just draw the different devices. Let's talk about man over here. Metropolitan area network. So you just see it covers a large geographical area connecting different lands from a larger network. Government agencies use MAN to connect to the citizens and provide industries. In MAN, various lands are connected to each other through a telephone exchange line. So you can see local area networks are connected to each other using telephone line. Mostly widely used protocols in MANs are RS-232, relay ATM, ISDN is example, and it has a higher range than local area. How to say the range, how far it can connect. So like airport itself, you can take it. This is a diagram. So let's see here what they have to say about metropolitan area. A man covers a larger geographical area than a land by interconnecting multiple lands, often within a city. Characteristics connects LANs using high-speed connection like fiber optics and telephone lines. Utilizes protocols like R23, R32, frame relay, ATM. You can always remember ATM, right? Just write ATM is also more than enough. Used by government agencies. See, government agencies, banks. See, airlines, like I said, airports, and universities to connect different branches of facility within the metropolitan area. Usually in India, you cannot see this every hi-fi colleges, but in foreign's usually is the same. Wide area network, that is WAN. A WAN spans a large geographical area such as country or even worldwide connecting. Talking about city, here we're talking about a country, okay, worldwide connecting multiple smart. Especially the example comes for WAN is banking transaction from one country to another country. Uses communication medium like telephone, fiber optic cables or satellite links. Especially fiber optics doesn't come here. Fiber optic cables are connecting through the ground systems, which are interconnected. Not interconnected, which is connected to satellite remotely. The internet is the largest example of WAN. Okay, so internet. So I said bank transaction that comes secondly. Internet is the largest example. Uses widely used by businesses, education institution to connect regional or international officers. I said regional. Regional and international officers. So let us see the diagram of WAN over here. As you can see, many servers are connected here with each other. So the key points you can see here about each thing. Just write the key points and complete it. Okay. So I have also made this in the tabular format, so that it's easy for us or everyone to understand. See here, description: a group of computers connected within a small area like a building or office. Area covered. Okay. A network connecting personal devices within a limited range of typically 30 feet. MAN, a network connecting multiple LANs within a city or a large campus. WAN, a network that spans large geographical areas such as countries and continents. See, range, small, nothing but building an office. Very small, individual area like 10 meters. MAN, city or large campus. Large cities, countries and continents. Key features: faster data transfer, inexpensive hardware, high security. Here, what is the features? Connect personal devices, low cost, typically wireless. Larger than LAN, connects multiple LANs, uses telephone lines or optic fiber. Same thing comes here, covers larger distance, high speed links, fiber optics, satellite, internet is a. So this is example: office network, school network, smartphone, laptop, wireless headset. So even connecting your earpods to your phone is also kind of personal area network, that is Bluetooth, right? Networks, bank networks, airline reservations. So bank can also come in man and run, because see, if you are just within city, you transact from different countries. So internet, global business network, government systems. I hope this was helpful for you. So we'll move on for the next thing, that is the network models. We will be talking about three network models. Is it just three or four? It is okay. See, okay, it's just three. Physical layering, TCP/IP protocol suite, and the OSL model. Having the introduction to physical layer. So about the computer network models. So here is the definition for the network model. So nothing but a conceptual framework that defines how the data communication between devices, how the data is communicated devices in a network. So that is nothing but network model. So what is a network model? It's just a conceptual framework which tells about how the data is being communicated between the different devices within a network. Okay. So things no need to see now itself, because it will be reading that below here. So protocol layering. First, write a definition for protocol layering. That is nothing but is designed in network models where the different functions of communication are divided into layers, or it is designed to divide. You can also say this definition. Layer actually is to divide the design into smaller pieces. So see here, provides modularity, clear into that is nothing but features. Services from lower to higher layer services. Then modification layer will not affect the other layer. No data is transferred from one layer n of one machine to the other layer n of another machine. It's just like each layer passes data immediately below it, not above it. Okay, until the lowest data is reached. That is nothing but a physical layer. So actual communication takes place. See, in layer architecture, unmanageable tasks are divided into several smaller and unmanageable tasks. So you just have to talk about a few things here, which this is a diagram over here if you just want to see. Same thing, layer 1, 2, 3, 4, 5, layer 1, 2, 3, 5, layer 1, 2, 3, 4, 5, protocol, 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 protocol. Last is a physical medium. So let's see here and understand. Okay. So we saw here, right, different function connection divided into layers. Each layer has a specific purpose of and communication with the directly adjacent to it. In the sense, one below the other. Okay. Key features of protocol: modularity. Each layer focuses on tasks, making the system easier to manage and understand. Service provisioning. Lower layers provide services to the higher layers. Lower layer provides services to the higher layers to ensure smooth communication and application function. Then independence, layers are independent. Changes or updates in one layer will not affect the layer, ensuring system flexibility. The flow of data moves from one layer to the other layer, starting from the top layer of the source machine down to the bottom layer of and the physical medium of the bottom layer of the destination machine. Just remember these four names. And modularity matlab kya? Each have their own task. Okay, and it is service provisioning. Layers provide service to higher layers to ensure. So in that sense, who are below you will help the ones above them for ensuring smooth communication. Independence, like if one spoils, it won't spoil the whole system. This that layer will be spoiled, and that layer. Data flow from top to bottom. I mean from first layer to the last down layer, that is physical medium. Layer interaction. Each layer has a clear interface with the layer above and below it. The top layer won't have a layer above it, and the bottom layer below it. The physical layer is the lowest layer and handles the actual transmission of data over the communication medium. See, example of layered architecture in the OSI model, open system interconnection. There are 7 layers, each with distinct functions. If you remember those about OSI model, you can just fill that here also, right? Writing all the layers. Then you have to talk about the conclusion. What is the conclusion? Network models through protocol layering provides a structured approach to the managing communication, ensuring flexibility, standardization, and efficient data transfer. You can simply write about flexibility and efficient data transfer. So see the key points. what is network modeling, what is protocol layering, benefits of it, and example. Over. Now we'll move for TCP/IP protocol suite. So I think okay, we have not completed half of the module yet. I guess with TCP/IP protocol it should be done. So here in this they have just given a small paragraph for that, saying develop prior to the OSI model, not exactly similar to the OSI model. 5 layers are there. First flow 4 provides physical standards, network inference, interconnecting, internet working, and that correspond to the first 4 layers of OSI model. These 4 layers are represented in okay like that. Main thing here you have to remember is this diagram out here. A few of them you don't have to elaborate the short form, but have to. Let's see those things here. So the TCP/IP protocol suite. Introduction, you don't have to mention introduction. If you mention it's actually better. The TCP suite is a set of communication protocols used for the internet and similar networks. मतलब suite set of communication protocols, same like you had the protocols in data communication. The protocols for it stands for transmission control protocol, internet protocol. Write in points so that you can just fill the space neatly, and forms a backbone of how data is transmitted. You can simply write that it forms a backbone of how the data is transmitted and received across the network. मतलब क्या sending and receiving. The model has 4 layers, each with specific roles and functions. You can simply write a layer of TCP/IP protocol suite. So see, they are saying 4 layers is respect to C 1, 2, 3, 4, 5, 6, 7 layers are there here, but according to them, this whole thing is one layer, like this, and then they just came like this again. But we'll see here what is there and we'll mention. So because they have said it has 5 layers, right? Application, transport, network, data link, physical. So application, transport, network, data link, physical. They have not included these two here. So here application layer, see I have highlighted the this layer provides application and ability that is nothing but to access services of the internet. Example are HTTP, FTP, SMTP, DNS. Comes are later in the further modules, module 3 or 4 I guess, and then functions include file transfer, email, and remote login. So what it does, it allows the access for applications to access the internet. There are few 4 examples. How much you remember, just right, and then you have to write the operation like file transfer, email, and report login. Transport layer is nothing but response for end-to-end and error handling. Full form is nothing but it includes two things, that is TCP and TCP and UDP. So transmission control protocol and user datagram protocol, and provides reliable communication through error checking and acknowledgements. Faster but less reliable. No need to write specifically this. If you remember, you can just fill the paper. Network layer manages device addressing, tracks the location of devices, determines the best data. So nothing but how the data can be moved. It will just guide you. It will track location. It's just like maps. So how Google keeps a track of everything where we go through the location, and also in maps like that it is. Device addressing, tracks locations, and data. Okay, then the primary protocol is internet protocol, responsible for logical addressing and routing. Then the data link layer. The data link layers deals with the physical transmission of the data over a medium, handles frames and access control. Protocols in this layer use Ethernet, ARP, RARP, nothing but reserves ARP, address resolution protocol, reverse address resolution protocol. It's just the things which are present in the diagram are being elaborated and explained here. Physical layer involved in the physical connection between devices. Physical connection is good for physical connection in between the devices. The transmission of the raw data bits over the communication medium. Physical means what? Usually physical itself. Difference between TCP/IP and OSI model. See, layers, 4 layer, and it has 7 layers. So you can simply make it as 5 because see 1, 2, 3, 4, 5 are there, right? So you can simply add here 5. Development TCP was developed before the OSI model and it is used widely in practice, whereas the OSI model is more theoretical. Basically, if we have to understand, TCP was made first and OSI was built lately, but the OSI Is less only like tutor type, just explains and makes others understand. It's just used for explanation, teaching. But for actual usage, we use this TCP/IP protocol itself. So what's the full form? Transmission Control Protocol and Internet Protocol. Okay. Then conclusion, you have to write this conclusion. The TCP/IP protocol is used for modern networking, providing a practical and efficient framework for communication over the internet. Practical usage is actually important. There is also a table below which we'll be discussing, which will be easy for you to understand. The key points here, see again, if you just read all these key points, should be enough for you to understand. Okay, so that at the end of the exam, if you just see this, it will be more than enough for you to remember all the points and then write again. So now we have to talk about the OSI model. See here, there are a bunch of how to say theoretical data over here. For each 7 layers, he has explained in depth like something which I did not like, so I have made the notes over here. So let's start with OSI model. So the OSI, nothing but Open System Interconnection, the full form. First, you have to write that the OSI stands for Open System Interconnection. It is a model. This model is a conceptual framework used for understanding and implement network communication. See, understanding and implement network communication, not for practical use, between different systems, developed by International Organization of Standardization in 1984, divides the networking process into 7 distinct layers, and each layer has its own unique specific function. So let's talk about, see, these are the 7 layers explained just so small. So actually this answer can be elaborated with the help of diagram. If we write the diagram, see, if I write this first and if I write the 7 layers and here it ends the question with these key points, it will usually take 1.5 page or 2 page in the exam. If you are a backbencher like me, then it will aram, so you can write this for also. And plus, if you are adding the diagram, it will become 4 pages. So one page can easily go to diagram, right? So you can just vertically 7 layers and just write some small one line description about it. See, physical layer. So deals with the physical connection between the devices. See, physical layer stands for physical connection between devices and the transmission of raw bit streams, same as what to say network model we saw there. Then functions include like line configuration, data transmission. See, line configuration, data transmission, simplex, half duplex, full duplex. Just write it again. Topology, just write the example: bus, mesh, star, ring, all those things. And signaling. Data link layer ensures reliable transmission of data across the physical network. Transmission, okay, way across a physical network. Then functions include framing, mostly what to say similar things there. Physical addressing, MAC addressing, flow control, error control. If you remove flow control, automatically error control comes in your mouth. And access control, see, control, flow, error, access, flow control, error control, access control. Data has control over the link. Network layer manages device, same thing I said, like Google thing it said, I told, right? Same like that, same thing you have to repeat. So basically you can repeat the 4 things from above here directly. See, the transport layer ensures end-to-end communication like we saw in that TCP/IP protocol, error checking, and basically they won't check. If you just highlight these things like this, what they'll check, they'll give you marks. Then let's talk about the additional layer, these 2 things. Session layer manages sessions or connections between applications. It manages sessions, connections between the applications. Functions include dialog. See, first what it does and its functions. What it is and its function includes dialog control, half duplex, full duplex communications. It's not what to say simplex type thing. Okay, and dialog control and signal, adding checkpoints in data transmission and for error recovery. Presentation layer translate, encrypts, and compresses the data. See, it translates the data, encrypts the data, compresses the data. Functions include translation, nothing, translation is converting data formats, encryption, ensuring privacy, compression, that is nothing but reducing the size. So you can see that compress into a zip file, compress into this, and then if extraction is nothing but zip file, so it will just make it big. Reducing the size of the data for transmission efficiency. Application layer, the closest to the end user, providing network services directly to the user. Functions include file access and management, mail services, and directory services, like your applications. See, I hope this was enough for you. Conclusion: the OSI model is a powerful tool that standardizes the networking processor, making it easier for various systems to communicate. Dividing the process into several layers, it allows for manageable troubleshooting and development of network technologies. You just write key various systems communicate by dividing. Okay, it standardizes network processing, making it easier for various systems to communicate. Then key points again, the OSI model. Okay. So like I say always, key points, just mention it so that it's useful for you to understand. Let's see for the diagrams here. Just draw this diagram. The first three layers are the data layer. This is the segment, transport segment. These four together combine the host layer, and this is the media layer. Okay, packet, frames, bit. See, these are in the form. See, data. Application. The data type is data itself. These are data. Transport layer has data is in segments. Trend network, the flow of data. Network is data is in packets. In data link, it's in bits. This is one diagram, and then simply mention these layers. It will take space, and then you can draw this diagram too. This layer provides the services to the user, responsible for transaction commission, and it will start with this section. See, topology defines the way how network devices are arranged, signals, data transmission, line configuration. Here, all expanded completely. Long thing. Anyways, you will be having these PDFs in the description, so just study from there. We will move on to the next, the introduction to physical layer. So before going there is a comparison. Okay, there are again comparison of OSI and TCP/IP protocol. So here the OSI model and the TCP model are two fundamental frameworks used to understand any communication. See, they had said about the differences. Here they are joining together and saying mutual benefits. Here, see now, features development. It was developed by ISO. Don't write in international standard organization. Okay. So here, as you can simply remember iPhone for this. That developed by the Department of Defense (DoD). Then their layers, just mention the layers here, 7 here, mention 5. Then purpose, conceptual framework for understanding and standardizing. See, understanding and standardizing here for practical model internet communication. Complexity, it is more complex, it is simpler. Reliable, it ensures reliable communication. But here it focuses on functionality and efficiency of data transmission. The usage, see, it's theoretical, understanding and teaching. See, usage and purpose are different. Purpose is for this. Okay, usage for theoretical purpose, understanding and teaching. This practical implementations of network communications. Protocol dependency. It is independent to any protocol, and here can work with any protocol stack. Okay, a protocol relies on TCP and IP for communication. See, we have two protocols in this. This what is a something protocol something, and this internet protocol. I know I forgot the transition control protocol something. Explain it more than enough. Layer interaction. So each layer has a defined function and interacts with the layer directly above and below it. See, it interacts with the layer above and below it. But layers are more flexible, and some layers can perform multiple functions. But whereas layer approach, it can only react to the below thing and can what to say improve the quality of the above layer for ensuring smooth communication. For OSI models failure. So actually this is a question. See, compare OSI and TCP/IP model, which I have compared in the table format. What are the reasons for OSI failure? Okay, so let's see that. It says about the OSI model. It says about TCP/IP model. Conceptual, 7-layer, complex, protocol agnostic, critical. TCP/IP model, practical, 5 layer, simple, built around TCP and IP, widely adopted. OSI model failure, these points again. Over. Introduction to TCP/IP model and logical connection. Okay, so this was one of the questions asked here. So what is meant by logical connection and TCP/IP? So we have already explained the TCP/IP reference with diagram. So we just have to talk about what is the meant by logical connection in TCP/IP. Okay. Actually, this is a detail and okay, so it's not much detail since it has answered the question separately. So the TCP/IP model is a conceptual framework. This is the definition of that framework that describes how the data is transferred over a network. It serves as a foundation for most modern networking systems, including the unlike the OSI model, which has 7 layers. The TCP/IP model consists of 5 layers that provide essential networking functions. It was developed before the OSI model and is the basis of the internet operation. Again, they have just compared TCP/IP with OSI and an explanation of it. So, in context of the TCP/IP model, a logical connection refers to the virtual connection. See, the virtual connection established between devices to enable communication. This logic connection, this logical connection is maintained by the protocol at various layers of IP. So each connection, logical connection, is maintained by the protocols in each different layers of TCP/IP model, and it is independent of physical medium. See, you have to remember this. It is independent of physical medium used for the data transmission. The logical connection ensures that the data is delivered to the correct destination. See, ensures data is delivered to correct destination without concern for the underlying hardware of the physical network. Okay. Then again, same thing about TCP IPC. Transport layer has extra additional explanation over here. Network layer, data link layer, physical layer. It actually this explanation has more what to say content which can be used again in model 2 just to elaborate your answers. Logical connections in TCP/IP. So again, a logical connection in TCP/IP refers to a virtual path. Okay, virtual path. So that is created between two devices or systems over a network. This path is abstracted from the physical hardware. Okay, abstracted from physical hardware, allowing communication between devices regardless of the physical infrastructure. So it will allow communication regardless of physical infrastructure. The logical connection is made use of network protocols maintained through network protocols that ensure the data routed correctly. Why? Network protocol that it is routed correctly, flows efficiently, and arrives at the destination intact. So, for example, when a computer connects to a web server, a website, a logical connection is established between a client and a server. So it's basically the same example which we have for other protocols sharing talking about client server model. So basically how if for example if you are querying about your order from Flipkart or Amazon, so you'll have the chat box, right? So you'll be talking to a server, getting responses from it. Then at the end, if it's not possible, then you call to the customer care directly. Any who what to say assistance from the company by themselves. So you'll directly call. Yeah, the call will be connected to one of the people of the workers or the staff of those. The connection is made possible through protocols such as TCP at the transport layer, which ensure that the data is sent and received reliably, and IP at the network layer, which ensures that the data is routed correctly. So basically, see, IP is for routing, and transport, that is TCP, a transport layer to ensure the data is sent and received reliably. So sending and receiving is taken care by TCP, and routing is taken care. For example, sender, I'm a receiver, so you will pack and you will send to me. So the route which is taken by IP. The send packages is done by TCP. Just an example for you to understand. So the key differences between the TCP/IP and OSI model: layer count. So layer count is mentioned how many layers are there. Structure. In TCP/IP, some layers combine functionalities of multiple layers. In the OSI model, so for you to understand this properly, if you try to see the diagram of TCP/IP protocol, so you can understand here that application layer has also taken the presentation and the session layer. Okay, so that's what it said. So here the has this IP. So main thing is this here over here. So with the application having additional layer of OSI model. See, that's what you are saying. The application layer in TCP/IP combines the functionalities of the OSS application, presentation, and session layer. We just have to talk about this session. So, where in application layer, two things are additional. Development. The TCP/IP was developed before and this developed late and specially designed for internet communication. While so TCP/IP model was designed for internet communication, and the OSI model was more general reference model. So, reference model. So, I, how did this happen? This error is it? Okay. Diagram OU, the diagram can be referred from your textbook. Okay. So I have just told you, right? So this is at the end again we have come to the key points: logical connections, TCP/IP model, application layer, network layer, physical layer. So you just have to talk about this. So first of all, we'll talk about main question here. They have asked us to explain this TCP/IP protocol itself with reference model diagram, and we have to what is meant by logical connection TCP. See, they have asked for only 7 marks. So what explain is for 10 to 15 marks. So you don't have to worry about remembering everything, whatever the quality is there. So you can just reduce it, right? So you can use that and just answer these questions in a more effective manner. What is logical connection? You can just write 4 to 5 lines about this, or 5 points is more than enough. Then you can explain about TCP. It will take more than 2 pages for you to complete. So 2 pages for 7 marks is actually how to say appropriate and efficient. Moving on. So key points summary. So again same thing we have said here. Then introduction to guided media transmission. Introduction to guided transmission media. So if you see now, we have come to this part now. Okay. So till now, okay, I mean we have come to this part, introduction to physical layer. So almost half of the module is done. Actually, it's kind of taking more than an hour to complete this. We just have few points left, so it won't be long enough since when we complete this module. We can look at the definition of physical layer. So again, introduction of physical layer is nothing but we are talking about the same physical layer of TCP/IP or that OSI model. You can simply rewrite the same thing about it, and it has some different key features or key functions. Total of 7. You can either just mention the headings and few things you can simply what to say elaborate like bit transmission or nothing but whatever the data we give, the computer understands only zeros and ones, right? So converts this data into zeros and ones and what to say uh, converts it into a signal. Data encoding and signaling. See, it encodes that thing into signals. So that is nothing but your data encoding and signaling. Bit the physical layer is one for conversion of data. So here it converts the data into either electrical memes or optical memes. Optical is nothing but transferring the data using optical cable. Electrical is nothing but your could be like that. And radio signal is nothing but the radio waves, the radio which you hear from your mobile or actual radios. Transmission medium through which the data is transmitted. 3 things: data rate control, synchronization of bits, physical topology. Should be easy to understand. Then we'll move to guided media transmission media instead of transmission media. So introduction to guided transmission media. So what is a guided transmission media? It refers to a physical medium. See here, it's all the same. So it's just a physical medium where communication like transmission of data usually through physical means itself, like what to say, optical fibers, cables. So you can to enhance your answers, you can simply mention twisted pair, coax cable, all those things. It is also called as bounded or wired media because the signals are confined to a specific path. What is the meaning of this specific path? Because already the path is predefined. That is nothing but it's what to say, cables, right? Wires, such as cable. Guided media includes copper-based cable, fiber optics, and others, all of which play essential role in data communication within wired networks. So it's kind of a proper what to say definition explanation. You can still elaborate this explanation by saying this guided media transmission ensures the efficiency and controlled transmission of data. Efficiency and controlled transmission, allowing devices to communicate with another through signals that travel along predefined path. saying what it allows a device to communicate with each other, intercommunicate with each other through signals that travel predefined paths. Signals are traveling along a predefined path, like I said, that are nothing but cable and optical fiber. These media are designed signal loss and interface while ensuring data reaches its destination accurately and reliably. In the sense, if you are transmitting data like sending a PDF file of images to your friend and the half of the suppose 90% of the loaded, but then the network goes off, the internet gets switched, off, turned off, by mistake, airplane mode. So the it just fails, right? So, but if you are doing the same with a wired thing, even it's on or off, or airplane mode is on or off, or Bluetooth is on or off, you just have to select the file and just for copy paste, so it will just work. Types of guided media transmission. So there are basically three types, in which in the question they have asked us to explain about cables. As you can see here, they might change this question saying talk about what to say. Where is this? Yeah, see, explain cable. They might ask you to explain the other two also. It's just what to say, your luck. So let us now start. Twisted pair cables is one of the most common and affordable types of transmission media. What do you have to say? It's common and most affordable. It consists of pairs of copper wires. So basically, the copper wires are present in this, well, in which the copper is coiled, okay, twisted together to reduce interference and cross. These cables are widely used in telecommunication systems, including local area networks such as LAN, telephone lines, and Ethernet networks. Types of twisted pair, there's unshielded and shielded. Talking about unshielded, same thing as the definition of just twisted pair. Most commonly used type consists of pairs of insulated coppers. So there only copper wires were there twisted together. Here insulated copper wires twisted together. They are used in the variety of telecommunication and network application, including Ethernet networking. Same thing, and Ethernet networking. So categories of UTP cable 1, 2, 3, 4, 5. Used for telephone lines, supports low speed data transmission, supports to 4 Mbps data rates, 16 Mbps data rates, 20 Mbps, and is used for long distance communication. 200 Mbps data rate used for modern Ethernet. Just same thing you can explain. Advantage of that: cost effective, easy installation, high speed LAN support like your Wi-Fi and all. Disadvantage: limited range, prone to inference. In the sense, the cable are effective and only over short distance due to signal attenuation. Prone to inference, since UTP lacks shielding, it is more susceptible to magnetic inference (EMI). Shield Shield TCP cables are similar to UTP cables that have an additional layer of shielding around the pairs of wires. Same UTP, but one additional shield is here. This shielding helps reduce the effects of electromagnetic interference. So that was an disadvantage, right? EMI affects it, prone for inference. But here the shielding, this inference won't happen. Okay, it reduces, not happens, but it reduces. Okay, making STP more suitable for with higher level of inference. Characteristics: higher transmission capacity, shielding, and cost. See, the STP has better capacity than UTP, supporting higher data. The extra shielding layers helps reduce signal interference, making STP suitable for environments with high level of electromagnetic noise. STP is more expensive than UTP, but still affordable compared to coaxial cables or fiber. Matlab, the remaining two types of what is this guided transmission media. So those remaining two, this is actually more cheaper and affordable. Disadvantage: higher cost and higher attenuation. In the sense, tends to have higher attenuation compared to UTP cables. Transmission media overview. Now, so we have completed the guided transmission media. Now, just talk about transmission. So, since we have talked about guided transmission media directly, this should be more easy for us to understand. So as you can see, the same thing is repeating again and again here. The transmission media is nothing but the physical. The data is transmitted in a communication system, or you can say a network. It carries data signals in the form of electrical or radio signals. Same thing. Transmission media can be classified into guided or unguided. So here, this is the additional thing. We will only Guided media, that is twisted pairs, coaxial cables, and fiber optics. It's a coaxial cable, whatever, same thing. Unguided is nothing but radio waves, microwaves, and infrareds, which we have also a separate question on that and separate what to say. Here we focus on guided media, which provides a direct physical path for data transmission. Types of transmission media, that is guided media. Again, just simply talk about guided media, whatever is there, what it does. Same thing. You can simply repeat this definition again and talk about twisted pair, coaxial cable, and fiber optics cable. See here, simple definition consists of a central conductor and an insulating layer, a metallic shield, and an outer protective jacket. It offers better shielding and higher bandwidth. Fiber optic cable uses light to transmit data through glass or plastic fiber, giving much higher data rate and longer transmission distance than copper cables. Unguided is nothing but radio waves, microwave, infrared is used in wireless communication such as Wi-Fi, cellular networks, communication. Microwaves used to point communication systems and long range communication, point to point or long range. Infrared used for short range communication like remote controls and infrared data transfer. Key factors of transmission media design: bandwidth, transmission impairment, interference. So data transmission rate, a medium with greater bandwidth can transmit more data at faster rate. मतलब क्या, the higher the rate of transmission, data transfer. Transmission impairment occurs when the received signal is due to factors such as attenuation, noise, or distortion. So key factors: transmission impairment occurs when the signal is degraded. मतलब क्या, whenever you are receiving a signal, actually due to some interference or disturbance, it's not clear. So the received signal is degraded due to factors. It is just degraded. Inference: the disruption of signals by unwanted signals leading to potential error in transmission. Conclusion: you can simply talk what is guided media, what is unguided, unguided, what do you have, unshielded and shielded, coaxial. You can simply just elaborate about it and write. Key point summary: guided transmission media includes physical media like twisted pair. What includes twisted pair cables? Transmission media supports communication channel by transmitting signals with factors like bandwidth impairment, interference, fiber optic cables. So that finishes about twisted pair cables, transmission media, and guided media. So now the other two types: coaxial cable and fiber optics. So coaxial cable is a widely used transmission media that consists of a central conductor, an insulating layer, metallic shield, and an outer protective jacket. It is called coaxial because the central conductor and the outer shield same axis. So that is coaxis. So let me write. It has a central conductor, insulating layer, a metallic shield, and outer protective jacket. Four things, right? It is called coaxial. So let us see if there are any diagrams over here for that. See here, twister pair cables and not jacket, twister pairs. So it just coiled around each other. Usually you have seen many cases like what do people do? It is just for usually for bulbs in everywhere. Then types of twisted pair: unshielded and shielded. You simply draw diagrams like this to what to say, fill the space. They have just talked about category 1, 2, 3, 4, 5, advantage and disadvantage, where is actual simple. See, it is cheap installation and of the unshielded twisted pair is easy for high speed LAN. The cable can only be used for shorter distance because of attenuation. This is disadvantage. Shield dead to one line explanation: characteristics, disadvantage, and coaxial cable. Sorry, disadvantage. Now the second thing. Very commonly used transmission media, for example, TV wire is usually a coaxial cable. This cable is coaxial and it contains two conductors parallel to each other. It has a higher frequency as compared to a cable. The inner conductor of the coaxial cable is made up of copper and the outer conductor is made up of copper mesh. The middle of non-conductive cover that separates the inner conductor from the outer conductor. So basically, you're just explaining. If you understand this, it should be a jacket, shield, insulator, center conductor. So you just have to explain about this. The middle core is responsible for the data transferring, whereas the copper mesh prevents from the EMI, electromagnetic interference. Okay, so Coaxial cable is of two types: baseband transmission, broadband. It is defined as the process of transmitting a time at high speed multiple signals simultaneously. So speed might reduce a little, not as fast as the baseband. So here are the advantage and disadvantage. Let's see what they have said. So structure of course, inner conductor, insulation layer, outer shield, outer jacket. So actually this thing has more content, but again, small. Just remember, a part of these answers is also more than enough to fill in the exam. You just have to maintain neat and just underline or outline this kind of keywords. Cis, baseband and broadband coaxial advantages: higher bandwidth, better shielding, reliability, high speed transmission, cost, fragility, complex installation. Same thing now for fiber optic cable is a type of transmission that uses light to transmit the data through glass or plastic fiber. Cables which transmit electric signals. Fiber optics rely on pulses of light to carry information over long distance. So it was there, right? It converts the data into electric. That is nothing but coaxial cable and your twisted pair. Converting into light is nothing but fiber optic cables. Converting into radio waves is your what to say unguided media transmission. So where were we? Okay. Fiber optics are known for their high data transmission capabilities and resistance to interference. So basically, your Wi-Fi router in latest, like nowadays, so whichever the cables are using, nothing but optic itself. Structure of fiber optic cable or optic fiber cable, both are same. So see, jacket cladding side view. This is the end view. मतलब क्या from front if you cut and see. Jacket. This is nothing but jacket. And this is your cladding. You can't see. Oh, you can see now. This is the core. core, core. Okay, basic elements of, so you have to explain what is core, what is cladding. It's basically your physics cycle, p cycle. Repeating over here again because I remember that this was there in physics. Following on the advantage of optical cable over copper. So advantage, they might sometimes state the advantage of this over what to say copper. So it's like just like that. See here, core cladding and jacket. Small exam explanation is there. Types of fiber optic cable: single mode fiber, multiple modes. This was not in that what to say textbook here, but in my own notes it's there. Advantage of optical fiber cable. Uh, Disadvantage of optical fiber cable. Conclusion, key points. See whatever is there. We can simply here comparison type they have said coaxial and optical fiber, coaxial and fiber optical cables. So now we should talk about the last second topic over here: unguided media, wireless transmission, radio waves and infrared. So unguided transmission are also known as wireless transmission. Guided refers to a predefined path, guided media transmission, but unguided is not like that. So it's just a wire. So that's why I say unguided. You are not guiding it, right? Refers to the transfer of data through electromagnetic waves without the use of any physical medium. If physical medium is being used, that is guided transmission media. If the physical medium is not used, this is the unguided transmission media. Unlike guided transmission media, which use cable or optical fibers, guided transmission media relies on the air or vacuum. Sorry for my accent. Air or vacuum at the transmission medium. This type of transmission is communication systems such as mobile network, satellite communication, and Wi-Fi. You can simply talk or write a few points about how use wireless things. For example, Bluetooth or Wi-Fi, connecting your musical instruments like headset, pods, all those things. The unguided media is divided into three primary categories based on the frequency range of the electromagnetic waves. You can simply say it is classified into three things, and then start mention or explain all these three things. They are omnidirectional, meaning that the signal is propagated in multiple directions from the source. In the for example, if you just light the bulb, it doesn't. It's not like a torch that it only focuses the light in a particular direction. Like a bulb which spreads like everywhere. So that's what they mean, omnidirectional. So you can keywords here: omnidirectional, travel through space, in all directions, meaning that, okay, characteristics of radio waves frequency range. Radio waves typically range from 3 kilohertz to gigahertz. So remember this 3 to 3 kg to 1 giga, not kg, but 3 kilohertz to 1 gigahertz. Propagation: radio waves propagate in all directions, allowing for broad coverage. This is why they are widely used in broadcasting. Omnidirectional transmission: radio waves do not require alignment between the transmitter and the antennas. So basically, there are few devices which requires antenna type thing. For example, your remote control toys. So both the controller and the car, it has antenna like that. So it's omnidirectional transmission. So alignment between the transmission and receiver antenna is not required as the waves spread out in all the direction. Because if there is two antenna, it will try to like connect. It's like someone is reading another's mind, right? It's like that. But omnidirectional, it's just like when I speak, everyone will hear it. Understood, right? Examples: FM radio transmission, AM radio, and television broadcasting. Television broadcasting is your YouTube live things or all those things also. TV and all. Application: broadcasting and wireless communication. Again, broadcasting is simply talk about YouTube, about making the videos, TV channels, weathercasting, and wireless communication, which is you use in your which you use in your day-to-day life. Advantage: wide coverage. Radio cover waves can cover large areas, making them ideal for broadcasting. Low cost. Radio waves transmission is relatively inexpensive as no physical medium is needed. What is the disadvantage? Inference. Radio waves are subject to influence from other signals or environmental factors. So much. If you just change itself, the inference occurs. Right? That's what they are saying. Limited bandwidth. The available frequency spectrum is limited, and congestion can occur with too many users. So that's all about radio waves. You can also check here about the radio waves at diagram. Earth surface, see, ground wave, ionosphere, Earth surface. Just one, and they have just talked us just 4 points here. Nothing much is there. If you just see, it's enough. This one is also enough. It's just like filtered, more filtered. This is qualitative, and this is just proper quality, but small. So if you have read this and then you are reading this, should be more than enough. Okay. Let's move to microwaves. Microwaves are high frequency electromagnetic waves. So the difference between this definition, like in radio waves, you just say electromagnetic, but here you just mention high frequency. So point to point communication, and they are unidirectional. मतलब क्या? You have antennas involved in this. Usually, very high, tall building, you will be having antennas over there facing towards a specific direction. And in the same direction, maybe far enough, there will be another building having antenna facing to the antenna. So that's why even your TV dish antenna, so they all space towards place, and they make sure that there is no obstacle in front of the antenna. So all these things comes under microwaves. So here unidirectional, meaning the transmission of data receiving antenna must be aligned precisely. So I can highlight this meaning unidirectional. Why is it not highlighting? Point to point communication. Types of microwaves transmission, that is terrestrial and satellite. This type of communication involves transmitting focused beam of radio signals between ground-based microwave antennas. So focused beam of radio signals. Then it is placed. Why is it not working? Whatever. The Microsoft Edge is actually showing kind of attitude issues with me, so whatever. Then the antennas are placed on towers to ensure that the signal can travel over usually a straight line offside. So what here it is nothing but the transmission involves transmitting the signals, I mean data, transmitting focus beams of radio signals between the ground based microwave transmission. What is this ground based microwave transmission? Nothing but two will antenna. The antennas are placed on towers to ensure the signal can travel over a long distance. So they are placed on top usually. Satellite wave is nothing but like your Google Maps. Uses of satellite relay signals between distant point on Earth. So nothing but Earth ground station are connected to specific satellites, and that signals are being transmitted from satellite to ground station and then from ground station to us, or either from ground station to satellite and satellite to Earth, like that. Characteristics of microwaves. Frequency range, unidirectional transmission, and line of sight. In the sense, microwave have frequency signal ranging from 1 gigahertz to 1000. That was kilo, right? Some kilos to 1 giga. Let's see how much kilo. 3 kilohertz to 1 gigahertz, and this is directly from 1 giga to 1000 gigahertz. Unidirectional transmission. Microwaves requires precise alignment between the sending and receiving antennas. Remember, line of sight, the communication path must be unobstructed between the antenna, that is direct line of sight. So this buildings or anything. Birds come but they go, that's not a problem. But usually fixed obstacle shouldn't be there. Application, terrestrial microwaves transmission, again same thing. Types have itself come in the application. Advantage, cost, you see, blah, blah, etc. So same thing you can see here. Satellite, see, terrestrial microwave, satellite microwave communication, they have directly explained it. Characteristics, advantage, disadvantage. Then satellite microwave, how does the satellite work? Advantage of microwave communication, disadvantage. Then we are moving for infrared rays. Infrared or IR transmissions use electromagnetic waves. So all are itself with frequency of the range of 300 gigahertz to 400 terahertz. Wow. So terahertz is like too much. Infrared waves are commonly used for short communication, such as between devices within the same room. Okay. So frequency is too much, so doesn't mean that distance of communication will increase. Okay, I'm just talking about frequency. Characteristics of infrared: frequency range, we have to mention. Short range, again repeat, is suitable for communication over short distances, typically a few meters. Line of sight, microwaves, like microwave, infrared communication requires a direct line of sight between the transmission and receiving devices. Security, infrared transmission is more secure than radio waves because it can not penetrate, but because it cannot penetrate walls, limiting the signal to be the immediate area. Applications: remote controls, short range communication, healthcare. So infrared is widely used in remote controls for televisions, display, and other consumer electronics. See, for example, your set-top box and TV. Shortage of used for data exchange between the devices like computer and smartphone, often for connecting peripheral like printers or scanners. Health, used in medical equipment of non-invasive sensing such as thermometer and pulse oximeter. Advantage: high bandwidth, low inference, security. So low inference because since the range is so low, hardly any inference can occur it, and it cannot penetrate walls either. So the frequency will be there, right? So because infrared waves cannot penetrate walls, they are less likely to suffer from the inference from external sources. With infrared offers a high data transfer rate of short distance communication. Security: infrared communication provides a secure method of data in closed spaces. Disadvantage: limited range, susceptibility of obstruction, cannot be blocked by obstacle like wall or furniture. It cannot be blocked from that. Environmental inference, infrared transmission can be affected by external light source such as light. So it's just like what to say, vampire. So sunlight affects it. Conclusion: unguided transmission media were all the three things you have to talk. Key points. Again, just see this. It should be enough for you to understand. Operation of connectionless packet switching network. So this is one of the questions asked here. The first question says the operations of connectionless packet switch networks with the help of neat diagram. So if you see the syllabus copy, this should be the last topic. Okay, computer networks, first module, and the last topic, that is about switching, packet switching, and its types. So here, let's first, instead of reading this question, we'll talk about normally about packet switching and its types. Switching is a process of transferring information from one computer to another. It is an essential part of communication in computer networks, ensuring that data can travel efficiently between different systems. Switches are small hardware devices used to join multiple computers together in a local area network. So switches don't mean this is power switches like turning on the computer or turning off. It's not like that. They operate at layer 2, data link layer of the OSI model, and switching is transparent to the user. Switching techniques include packet switching, where data is broken into smaller packets and sent across a network. Packet switching, which is not the focus here, will focus on packet switching and its types. Okay. So, what is packet switching? It is a method of data transmission where a message is divided into smaller packets. These packets are sent immediately and may take different paths to reach the destination. So, in the example, like dividing your like 1 to 10, a stick is there, you're just dividing into 10 equivalent parts. So, now what they'll do are travel individually. Like if there is a path like W, so these things can go in direction, three directions also, but at the end will reach to the same destination. Key characteristics of packet switching: message division. The message is broken into smaller pieces called packets. Since it is broken into smaller packets, if one packet fails, the other get affected, right? So it more efficient. Like for example, sometimes if you're transferring, something goes wrong. It goes wrong. Like just the image place might be like not be displayed, but every whole data will be displayed. Unique identification. Each packet is given a unique sequence number to maintain the correct order when reassembled. Some arrive earlier, but it is not the first packet. It will be a middle packet. So sequence number. Because of that, it will headers. Each packet contains crucial information such as source address, destination address, and sequence number. Independent paths reassembly. Independent paths means what packets may take different routes across the network depending on the paths. Reassembly, error handling. If any packet is lost or corrupted, the request is made to resend the missing or damaged packet. Acknowledgement: once the packets are received and reassembled correctly, an acknowledgement is sent back to the sender. Advantage is nothing but cost effective, efficient, and reliable. So efficient is what multiple users can use the same communication channel at the same time, and reliable is what if a node is busy, the packet is rerouted, ensuring communication continues. So like if you see a traffic, usually you try to take U-turn and go through path, right? Even though the path is long, but the time takes less. Disadvantage: high delay. Sometimes, see, as you can see, railway tracks come while you are driving. Traffic signal, no matter how, there is a track on that place. So, like, you just have to cross your rail track. Right? So, obviously, the bike jam, traffic things is there. Application requiring low delay and high quality service may not work well with packet switching. Complex protocols are complex and can increase the cost of implementation. Network overload: if the network is overloaded, three lost packet is required, which can lead to delays and data loss. That's it. So we can also see about switching over here, which has quite a small what to say types of explanation. There was just a few 1, 2, 3, 4, 5, 6, 7 points over here. Let's read that. The packet switching technique, which is use of message in is sent in one go, but it is divided into small and they are sent individually. The message split into small pieces known as packets, and packets are given a unique number to identify their code. And so, what I have to say again, you don't have to explain all these thing headings like that. It's just key points you can mention. If you use, it's good. But still, with the proper knowledge, even though you are not able to mention these headings over here, you can still explain them. Every packet contains some information in its header, such as source address, destination address, and sequence. See, you just in my notes, you had what to say points over here like headings. Packets will travel across the networks, taking the shortest path as possible. But some path is busy or something, you will reroute and go to the another path. But might uh, it might lead to delay. All the packets are reassembled at the receiving end in the correct order. If the packet is missing or corrupted, request will be sent. So again, the from the side, the packet will be sent again. If the correct order of the packet is reached, then the acknowledgement will be sent. See, 4, 3, 2, 1. 4, 1 has went here. 3, 2 has went here. Then here, 1 is here, so it 4 here. 2 goes there. Then again 4 is rerouted, 4, 3 goes here together. 1 is here, so 1 goes Goes here. See again rerouted 243. Again sent here 2431. Then again 4321 1234 like that. So here 2431 is there. It will reroute again and then it will be sent like that. A simple diagram you can understand by yourself, right? So this is also a basic diagram for what to say your DSR algorithm. Sorry for bringing that here. So types of packet switching, datagram packet switching, and virtual circuit switching. So I think there are just two types. Let's see the question what they have asked. Packet switch networks with the help of describe the operations of connectionless packet switching. Okay, so we'll also move on to that also. Now let's talk about types of packet switching is broadly classified into datagram packet switching and virtual switching. Okay, so first we'll talk about the datagram packet switching, connectionless switching. See, in the question, if you didn't know about this name, you will think connectionless packet. What is that? That is nothing but datagram packet. Okay, so connection. So independent packet. In this type, each packet called a datagram is treated as an independent entity. Routing. Each packet has its own destination address, and the network decides the route for each packet. No fixed path. The path for this each packet is not determined, and each packet may take a different route. Reassembly. Once all the packets reach the destination, they are reassembled in the correct order. Advantages: no need for an established connection, which makes it flexible. Disadvantage: higher packet taking different routes, which may lead to issues like packet loss or delay. So see here, I won't be seeing this right hand side path. This side, oh, it's working now. I'll just see independent packets in the sense what whatever the message is divided into packets, all the packets are independent. They are treated independently. So routing, what is routing? So the packet routes which are taken is not predefined. I'm saying so it is not predefined and can take any packet. Then third, no fixed path. Okay, so sorry, routing, no fixed path means that it won't travel through a specific path, can take different path. Routing means it has its own destination. At the end, it will decide which route, network will decide which route to go. Reassembly, once all the packets are reached, assemble and send the acknowledgement. Advantage, no need to establish connections, which makes it flexible. So no need of establishing a connection. Disadvantage, higher chance of packets taking different routes, which may lead to issues like packet loss or delay. It happens, right? Sometimes. Virtual circuit switching. So we'll talk about this and then we'll move to the question. Pre-planned route. A fixed route is established sending any packet. So opposite. So there it's not a pre-planned, like independent. Here pre-planned is there. This is called secure. Call request and accept. Before the communication begins, a call request is sent to the to establish the connection. Follow call accept. So if I want to establish connection, I'll send this call request, and then the other side, receiver side should accept. Then only the connection is established. Now the transmission begins. Fixed path. Once the route is established, all packets take the same predetermined path. Okay, same path. Reliability. Since the path is fixed, the packets are delivered in the correct order and with minimal delay. So here there is no need of reassembly. It will be in order itself. Application used in applications requiring reliable and continuous data streams such as video conferencing or VoIP. So it's something Internet of Protocol VoIP. I don't know what is the what to say elaboration of V. You can just type in the comment. So key points. So you have to talk key point packet switching divided into packets each with a sequence number and destination address. Packets may take different routes and are reassembled in the destination and then sends the acknowledgement. Two types, datagram and virtual. Datagram is what? Connectionless, no fixed path. Packets are routed independently. Virtual circuit switching, connection over fixed path before the communication begins. Advantage of packet switching, cost effective, efficient and reliable. Disadvantage of switching, high delay, complex protocols and potential data loss or delay due to network overload. So we'll move to the actual question, mostly about datagram itself over here, right? See, operation of connectionless packet switching network. So this question, let us start. In a connectionless packet switching network, each data packet is treated independently Same thing about data diagram, meaning there is no need for an established path or connection between the sender and the receiver before the transmission. This is also referred to as datagram packet switching. That packets are routed through the network individually. In the sense what? Network decides which route to send this packet. So packets are there. This network will decide the routes for these packets. And each packet may take to reach the destination. Key characteristics: no pre-established connections are there. Matlab kya? So connection is happening each packet is right. So there is no need of connection. Like unlike connection-oriented packet switching, whereas the path is established before coming. So what he's saying, very smart. Just to fill the paper, he's saying unlike the virtual circuit where the connection is required, correlation-oriented path. Here, it is a connection-less packet switching. Does not require a dedicated path. In the sense, what this no connection what says we don't need a dedicated or predefined path. Packets are independent entities. So whatever the datagrams which are being made or divided from the data is treated independently and has its own source code and source address and destination address. Each packet contains the necessary information such as source and destination addresses to navigate through the network. Routing decisions: intermediate device routers or switches make routing decisions for each packet based on the packet destination and the network's current state. So you can simply also take as the network decides or to route the reassembly at the destination. Again, same thing. Once all the packets are arrived at the destination, reassembles and then sends a what to say acknowledgement. Steps in connectionless packet switch network: message division, packet routing, reassembly at the destination, acknowledged, and error handling. Error handling is a sense if any packets are lost or missing, it sends a request for resending that packet. And advantage: the efficient use of resources. See, it was very simple, right, to answer. Nothing much was required itself actually for us. It was so simple to explain, rewrite few things again and again and just write off. Advantages of a connectionless packet switching: nothing but efficient. Since no dedicated connection is established, network resources are shared efficiently. In the sense, what this is not established, right? So there's no chance of connection being breaked or something like that. So if the road breaks, we'll just take a. It's like that. The network sources are shared. Multiple users can transmit data simultaneously without waiting for exclusive access to the communication channel. So it's just like public source type. Okay. In the private, you need some request, but here it's just public. Flexible routing. In a sense, what you just read this definition. I'll give my own. In the sense, if a route is busy, it will just take the other part like that. Cost effective. No need of maintaining connections to information across the network, which reduces the overall method. More cost effective. See, it's just like they have not asked advantage. Have they? See, they did not ask any advantage. With the help of diagram, they have said. We'll see the diagram here. Oh, they have not given any diagram. So why not we use this diagram itself? Who cares, bro? Just use it and finish it off. Disadvantage: unreliable delivery. No guarantee the quality of the service. We can't ensure that everything will reach. Sometimes it will keep on breaking again and again. A loss of data like that and all. So diagram, since you have the diagram, you can illustrate the connection as packet switch network. So sender, router switches and destination. So sender, receiver, router switches S1, S2, S3. Yeah. Oh, bro, see key points. Connectionless package between package, reassembly, disadvantages and advantages. If you just do like this and write a conclusion, so you'll get out of what marks, bro. Four basic topologies used in networks. So this was a question asked in the model paper. I think so. Yeah, see, explain the four basic topologies used in the networks. List advantages and disadvantages of each of them. So basically, we can write about the network topologies because it's very easy, but we may lose marks when it comes to writing the advantages and disadvantages. So four basic topologies are bus, star, ring, and mesh. So the bus topology, all devices are connected to a single central cable known as the bus. The data sent by along the bus and received by all devices. So a bus is traveling and one by one it takes like how left and right people are sitting. You're just walking in the middle. Whoever wants the food, you're just putting and you're going like this scattering. This example I give for you to understand. But only the intended recipient processes the data. If you don't mention this point, is also it's okay. Advantages: cost effective, easy to install and expand. मतलब क्या? Burst of less cable, than other topologies, making it relatively inexpensive to set up. Only one cable is there, right? Easy to install. It is simple to add devices to the network without much disruption. Disadvantage is network failure is if the main bus cable fails, the entire network can go down. Wow, what a downfall. Limited scalability. The network grows, performance degrades because the bus can only handle a certain amount of traffic. So it's just like too much, right? See, if more network what to say connections are there, it means the more demand of data, whatever the transfer, everything will be there. So obviously the performance degrades, right? Then data collision. Sending data at the same time can cause data collisions. For example, if you take just normal bus example, one station, one bus stop, someone is sending another bus stop is sending, but it is in first bus stop. So sometimes, right, so data cannot be taken properly. So data collisions at the same time, two places. So where it will go? It will get stuck, right? It's not programmed like first do this, then do that like that. So that is the advantage and disadvantage. Just remember the key point is more than enough. Star topology is a star topology. You just have to draw a star in this, and then just put circles and say those are the devices. For your help, I can simply draw like this. I'm drawing from mouse, so it's not so clean because I'm not used to all these things. Just draw like that. Do it. All devices are interconnected to a central device called or switch. Okay, here will be your whatever hub or switch. Each device has a dedicated point-to-point connection to the hub, or you can simply say, "Array, yeah, this is more better, right?" Even if I use a trackpad, it's not that neat, and I'm wasting my time. Anyways, what's it? So, data from a device is sent to the hub, which then forwards to the correct devices. Okay, so read again. Data from a device is sent to the hub, which then forwards it to the correct device. Advantage: centralized management. The centralized hub allows for easy management and troubleshooting of the network. Isolation of device. If one device fails, the rest continues to function. Scalability. New devices can be added easily without affecting the rest of the network. Then disadvantages. So isolation is what? If one fails, another is there to keep running. Scalability, you add without affecting the previous things. This one is a single point of failure. If the central hub or switch fails, the entire network becomes operable. There, central bus was there. We had a central hub type of thing. So it was there one by one. Here it is all together. Same disadvantage, right? Single point of failure. Then higher cost. The central hub or switch increases the overall network because of that single hub. Performance dependency on the hub. The performance of the network depends on the hub's capability to handle multiple connections. So the disadvantages are very easy to understand here. Ring topology. Ring. Don't put one diamond over here. That's not the kind of ring they are saying. It's just one circle type of thing. In a ring topology, devices are connected in a circular fashion with each exactly two connections. One to the device of the left and it's very simple, right? See, if one device is here, another device is here, right? See, and another device is here. So how it is connected? See, here one connection is there, one connection is there. If here I put, see, for this thing, here two are there. For this thing, here two are there. For this thing, like that, it is simple. One on to the device on the left and one on the device. Data travel is unidirectional or bidirectional manner around the ring until it reaches the intended device. In the sense, what it's basically unidirectional. So this wants to send here. So suppose there are, if I have to explain it properly, there are five things means like this is ring, right? So from here data should go and it has to reach here. Okay, now here see one two, here is one two three. Network is more challenging compared to the other topologies. See, again you have this proper key points where it has a one line definition of topologies and advantages and disadvantages with it. No, oh man, where did I stop? I have to check, bro. So see now if data has to be transferred, so it can from this device to this, it can either go here or here. Sorry for the any what to say inference in the between because the recording has take, so I'm just explaining again. So advantages you can see here, data moves in a predictable direction, avoiding the risk of collision. So if data is bound like move from here, so okay, simple to install, easier, efficient for small networks. Okay, it's very simple, very efficient too. Disadvantage or single point where here it breaks, right? This system failures, entire network goes down. Performance duration, if you increase more devices, performance decreases, and if it is a closed loop, if there is an error in somewhere, you cannot identify it very easily. It's very difficult to locate. That's what all the disadvantages. Mesh is nothing but all the devices are connected to each other. So one device is connected to all the other devices. So, direct communication link. So that's what they have said in explanation. Advantages of fault tolerance. If one, what to say, connection breaks, it has multiple other ways to send to that particular device through other connections. High reliability, provides high reliable connection due to multiple connections. Scalable, adding more device won't affect the existing device. Disadvantages, because it is interconnected to each other, the cost can also be increased because the more number of cables are required. Complex installation, because devices, it's very complicated to install in large number of connections. Maintenance difficulty, due to the complexity, many network is more challenging compared to the other topologies. So here are the key points which should jog your memory before the examination, and this is the end of the module 1, and you people have already closed, I guess I know that. So if you are kind enough and you have some shame, just like the video and subscribe or whatever it is, share it, man. You people want to just leave already.